Hello everyone! In this video, I'm going to show you how to implement the pruning in the recursive function. Well, recursion is great because it can explore all possible cases, but that's also its biggest weakness. It explores too many cases. This is why recursion is often considered slow. So to fix this problem, we use a technique called pruning. Pruning means that stop exploring paths that are already invalid. So let's dive into the most basic and important pruning pattern. Well, first things first, if you take a look at this tree-shaped structure, imagine a three-digit dial lock. So each dial can be set to a number from 1 to 4. However, there is a safety rule. You cannot select the same number twice in a row. So in this recursive solution, level represents which dial we are currently setting. So the level will be 3. And the for loop represents all possible choices for that dial, which is branch 4. And in this example, I'll show you two different versions of the code. In the first version, we prevent the wrong choice before entering recursion. If the current choice is the same as the previous one, we immediately skip this branch before making an invalid choice. For example, if we take this pass, we're not allowed to get into this pass, this branch, because this is the consecutive numbers. And if we get into this pass, 1, 2, and then we are not allowed to get into this branch as well because 2 and 2 is the consecutive numbers. So by doing this, we never explore invalid combinations. And so in the other version, we enter the recursion first. So 1 and 1. And then we detect that the choice is invalid. So we return immediately. Both approaches will behave exactly the same. And in terms of performance, there is virtually no difference in speed. So depending on the type of problem or example, well, one style may be more preferable or more readable than the other. Well, now is the coding part. So I'm gonna write down the basic code again. Well, I'm gonna name our recursive function as a tree. If level is 3, I'm gonna print out a pass. And I'm gonna return it. And after that, I'm gonna skim through all the branches that we have. And I'm gonna leave the trace using the pass array. When I come back, I'm gonna erase the pass. Well, if I execute this code, well, there is the entire combination of the choices without the safety rule. But we know that we have the safety rule, so we need to check with the red color. So for example, when we take this pass, we have the 4 choices. So in this case, there is the 2 consecutive numbers. So we're gonna skip this branch. But in this example, with this method, we have to uh, go deep down level, at least level 1. So the level should be upper than 1. And the pass, we need to compare with the previous choice and with the numbers that we're about to take right now. So if this result of this operation is true, which means that we violate the safety rule, we have to skip this branch. right now. So if I execute this code, well, there is no consecutive numbers twice in a row, as you probably can tell. Well, this is version 1, but there is version 2, as I already mentioned before, with the blue one. If I take this pass, and if I take this pass again, well, this method checks it after the choice is made. So we detect that this is the wrong branch. So once we detect it, we have to go back to the previous level. So in this case, we need to go deep down, at least level 2. So in this case, if level is upper than 2, and we need to compare with the past record, like this. So in this case as well, if this result of this operation is true, which means that we violate the safety rule, I'm gonna return immediately. Well, the result of this code is exactly same. So what I'm trying to say is that even though these two pruning methods look different, they enforce the same rule. One method checks the rule before making a choice like this, which is version 1, and the other checks it after the choice is made, which is version 2. So because the rule itself is identical, all invalid paths are removed in both cases. The only difference is when the pruning happens. So just so you know. Well, this tree-shaped structure represents choosing 3 drinks from a vending machine, and each branch selects 1 drink. And each drink A, B, C, D has the price, each price, which is 2, 3, 4, 5. So each branch selects 1 drink, and we prune the branch if the total cost exceeds the budget. And so we need to add the parameter in our recursive function tree with sum. And for example, if we take this pass, the budget right now is 5. And if we take this pass again, the total budget is 10 right now. So, which means that we exceed the budget, which is 10 already. So we need to prune this branch. And in this case as well, if we take this pass, the total budget right now is 9, but we're not allowed to get into this branch because it will exceed the budget as well. So we need to prune this branch as well. Well, I'm gonna write down the basic code first. In this case, we need the sum parameter as well. So there's the 2 parameters of our recursive function. If level is 3, I'm gonna print out the pass and sum. And I'm gonna return it. We have the 4 choices of our drinks. Well, if we choose the drink, I have to add the price with the current sum value. When we come back, I'm gonna erase the pass. So the price would be 2, 3, 4, 5. Copy. There we go. Well, this is the all combinations that this function can make, but we have the budget rule. We're not allowed to exceed 10 with this budget. So in this case, with the version 1, well, version 1 checks the rule before making a choice. So in this case, sum plus price I should not exceed budget 10. And when we violate this rule, we have to skip this branch right away. So, well, this the sum, the total amount of the budget is all under 10. But if I write down the version 2 code, which we already make the choice and we detect that this is the wrong branch, we have to go back to the previous level immediately. We need to check the sum. In this case, if sum is exceed 10, I'm going to return it. So the result of this code is exactly the same, but as you probably can tell, as I already told you, well, the only difference is when the pruning happens. So that is the only difference in this code. Well, if you take a look at this example, this is our last example of this video. So imagine we are preparing an art exhibition. We have 5 different paintings from different artists, but only 3 wall slots. Each wall must display a different painting. A painting cannot be used more than once. This is why we need the DAT, which will be named as visited. And the size of the visited array must be at least as large as the number of the branches. So in this case, the size of the array would be 5. So for example, if we choose the painting A, there will be no extra painting left with painting A. So this branch is impossible. This branch is nonsense. So with the same concept, if we take this pass E, then there is no extra paintings as well with the E. So this branch is nonsense, impossible. So whenever we get into this pass, I'm gonna check the DAT array. So this is how it works. Well, I'm gonna write down the basic code first. If level is 3, which means that we have 3 wall slots, I'm gonna print out the pass and then return it. We have 5 choices of our paintings, and I'm gonna record our choices. So paint I, and when we come back, I'm gonna erase the pass array. We have 3 levels, and we have 5 paintings, A, B, C, D, E, and we're not going to choose the same paintings in the same pass, so we need the visited array. So if visited I is selected already, we need to skip this branch. Otherwise, we're going to select it, the painting I. There we go. And if we come back from the recursive function, I'm going to erase the visited array as well. So if I execute this C file, gorgeous. Well, the visited array is about remembering the past decisions so that we won't choose it again. Well, the visited array remembers the history of our choices. So this is all about today's video. And I hope you find it very useful through this video. Well, thanks for watching. See you in my next video. Bye guys.